gold packet. Question number 1 says, write the balanced chemical equation for the reaction between aluminum and an aqueous solution of sulfuric acid to make aluminum sulfate and hydrogen gas, include all states of matter. So I already have the balanced chemical equation written here on the paper. So aluminum in its elemental state is going to be Al with a solid state of matter. Then we have sulfuric acid, which is going to be aqueous under the conditions of this reaction, followed by aluminum sulfate as our first product, and hydrogen gas as our second product. Remember that hydrogen gas is one of your 7 diatomics. So in this reaction, when it's present as an elemental state, its chemical formula is H2. Overall, the balanced chemical equation tells us that 2 moles of aluminum plus 3 moles of sulfuric acid yield 1 mole of aluminum sulfate and 3 moles of hydrogen gas. So when we look at question number 2, it says, what mass of hydrogen gas is produced if 300 milliliters of a 1.5 molar solution of sulfuric acid reacts with excess aluminum? Okay, so if we look at the details in this particular problem, we're looking to calculate a mass of hydrogen gas. We have solution information about our sulfuric acid, and we know that we have excess aluminum. So remember that aluminum is not going to factor into this problem. We're looking at the relationship between sulfuric acid and hydrogen gas. So that in this reaction for my sulfuric acid, I know that I have 300 milliliters. And I know that the concentration of my solution is 1.5 molar. Okay, in this reaction, I'm going to need to do a calculation on the mass of hydrogen gas. The molar mass of hydrogen gas is 2.016 grams. Remember that the molar mass just takes into account the chemical formula of H2. The molar mass does not consider this coefficient of 3. The coefficient of 3 gets considered as we go through and do our stoichiometric calculations. So that as we start doing the calculations for this problem, we're dealing with a solution. So we know that our molarity is equal to our moles of solute divided by our liters of solution. So we need this volume of 300 milliliters to be in liters. So that's going to be 0.3000 with units of liters. We can plug this into our molarity relationship or use molarity as a conversion factor. So if we know that our molarity is 1.5 moles of our solute, which is sulfuric acid, divided by 1 liter of solution. When we do that calculation, we find that we have 0.45 moles of sulfuric acid. Okay, 0.45 moles of sulfuric acid. Now, in the next part of the question, in order to relate sulfuric acid to hydrogen gas, now I need to do a stoichiometric calculation. For every 3 moles of sulfuric acid that I start with, I will make 3 moles of hydrogen gas as my product in this reaction. So I'm going to take my 0.45 moles of sulfuric acid, and I'm going to use the coefficients in my balanced chemical equation as my conversion factor. So that's going to give me 3 moles of sulfuric acid in the denominator, and that's going to give me 3 moles of hydrogen gas in the numerator. Okay, so that in this reaction, I am expecting to make 0.45 moles of hydrogen gas. The final calculation means that we need to convert to the mass of hydrogen gas. So I need to take my 0.45 moles of hydrogen gas times the fact that 1 mole of H2 has a mass that we calculated up above of 2.016 grams. And when we do the calculation, our final answer should be 0.91 grams. Okay, 0.91 grams. In the information given to us in the problem, we have 2 significant figures here in this molarity value. So that's why my final answer here has just 2 significant figures. In question number 3, you're asked to calculate the molarity of aluminum sulfate at the end of the reaction described in question number 2. Assume that the final volume of the reaction is 300 milliliters. In order to do this, we need to look at the stoichiometric calculation between our sulfuric acid and our aluminum sulfate. And we see that we have a 3-to-1 mole ratio between these 2 components. So I know from my calculation up here that I'm starting with 0.45 moles of sulfuric acid. In this question, I'm going to do a stoichiometric calculation to relate my moles of sulfuric acid to my moles of aluminum sulfate. Okay, and in order to get that conversion factor, I'm going to go up here to my balanced chemical equation where I see I have a coefficient of 3 in front of my sulfuric acid, a coefficient of 1 in front of my aluminum sulfate. So that's going to give me a 1/3 conversion factor. When I do the calculation, I get 0.15 moles of aluminum sulfate. Okay, 0.15 moles of aluminum sulfate. Now, if I know my moles of solute, I know that my final solution volume is 300 milliliters. Now I can calculate my molarity. So my molarity is going to be 0.15 moles of my aluminum sulfate divided by 0.3000 liters. And so the molarity that you calculate is 0.50 molar.